Hi, I'm Dr. Charles Harry, and welcome back to Cybersecurity for Everyone. In our last episode, we talked about the application layer as part of this process of encapsulation. And in this episode, I want to talk a little bit more about how information actually routes on the internet. And so therefore, we're going to talk about something called the network layer. We're now talking about the portion of the stack that deals with routing information between independent networks. So how does data route across the internet? And so the fundamental problem here is that I want to move my data from my location to somewhere around the world. The problem is that there are a lot of independent networks that are changing constantly. So how do I know where and how to get my information across the planet? That's the question. So there are a couple of different things that we need to address. First, where am I going? We're going to talk about something called an IP address or an Internet Protocol address. Second thing I may want to know is what local road should I take? We're going to talk about something called autonomous systems. And third, how do I know what roads connect to where? So we're going to talk about something called a peering relationship. Answering these basic questions gives us a little bit more insight on how data routes from one point of the earth to another. So where am I going? Let's answer that question or try to address that problem first. So we're dealing with something that we call the Internet Protocol. And it really acts as an address on the internet, similar to your home address. The Internet Protocol assembles data from all the layers above it into what we call a packet with an address header. So kind of like an envelope with the address on the outside. And they basically says something like, please deliver this information to something like 8.8.8.8, which is an Internet Protocol address. So what road should I take? We want to talk about something called an autonomous system. An autonomous system is basically a group of IP addresses that are managed by an organization, and it makes routing information between these independent networks easier. It might include large networks like AT&T, Sprint, or Verizon. It could also include other large organizations like IBM. The goal is to have these independent organizations that manage thousands of Internet Protocol addresses communicate with one another. So what does that actually look like? Well, in this diagram, we have a very simple model with a variety of different independent networks broken up by their AS number, AS 1, 2, 3, 4, 5. And you'll notice that they're color-coded. And the color represents the different organizations that manage those devices and the Internet protocols that are associated with each of those particular devices, those IP addresses. So the autonomous systems can connect to one another, but the question is, which autonomous systems connect with one another and which ones don't they connect with? Because you can imagine there are tens of thousands of autonomous systems all around the world. Not all of them are going to be directly connected to one another. So how do we know which ones are connected to other AS structures? So how do I know where the roads connect? We want to talk about peering relationships. So autonomous systems, these group of independent organizations that manage these thousands of Internet Protocol addresses, have to have some way in which they relate to one another. We call that a peering relationship. So an AS provider will broadcast a list of other independent networks it has a connection with. It uses something called the Border Gateway Protocol. We're not really going to talk about that in this episode, but there's another set of instructions in which it uses to do exactly that. So even if your AS, your autonomous system that you're a part of, does not know where 8.8.8.8 is, perhaps one of its neighbors does. That information, your information, is forwarded to a neighbor of that AS structure that knows where to send that information. So this is just a quick example of a peering relationship of one AS. And what you'll see in this is that there are a variety of different AS numbers that this particular autonomous system has a relationship with. And the goal is that as I'm requesting information from websites all around the world, some of those AS structures that I have a relationship are going to know where to route my information to. That's the advantage of having peering relationships. So when I take a look at the large interconnections on the internet, the value of having autonomous systems and peering relationships is it gives you a sense of where to route data. So why does this matter? Well, vulnerabilities, just like when we talked about the application layer, vulnerabilities exist in several of these protocols. Hackers can use those vulnerabilities to gain access or to achieve an effect. Software developers who are not careful in the design of their software might introduce new vectors of attack, and network engineers who don't configure their networks appropriately might introduce other attack vectors. So again, complexity of human and technical systems is at the heart of cybersecurity. Understanding each layer in the stack is fundamentally important if you want to protect yourself. So what can we take away from this episode? Well, first, that information that deals with routing is done at the network layer. Locations on the internet, or IP addresses, are established by the Internet Protocol. Autonomous systems are organizations that manage large amounts of IP addresses, and they relate to one another using peering relationships. In our next episode, we're going to talk about the physical layer, how energy actually moves from one point of the Earth to the next, and how all this information that's been encapsulated is transmitted. I hope to see you next time.